Number 4 says, consider the function f of x is equal to 4x cubed minus 5x squared plus 3x minus 15. So because x was not defined, it is general. So x can mean anything. T, we normally know t for time and s for space, distance. But x could mean anything, and f of x could mean anything. Always bear in mind that f of x can be written another way. F of x is the same as y. Okay. So y and x could mean anything here. So that's general. So there's no really interpretation going on there. Okay. The only interpretation is the whole sequence of the solution. All right. So you say determine the behavior of the function when x is equal to 5. Determine the behavior of the function when x is equal to 5. Unit 9. Now, when we're talking about the behavior of the function, meaning in terms of how the function is it increasing? Is it decreasing? Does it have a positive gradient? Does it have a negative gradient? Okay, that's what is actually meant by the behavior. Let's just do a little quick visual. Okay, you have, let's say, 4x raised to the power of 3 subtract 5x raised to the power of 2 plus 3x subtract 15. Okay, 4x cubed minus 5x squared plus 3x plus 15. Okay, and here you have a representation of it. And this now, what we have there is 50. So 10, let's put for the x, let's put this as 10. Okay, let's put this as 5. I can change this as 6. Okay, and the y, you can put the y as negative 50 or negative 10 and positive 10. Okay. So that's like a little section there. That's 10. Okay, so probably want to shift this to, let's say, 5. Okay, let's see what happened in there. 5. Okay. That's a little section of the curve. All right. So when x is equal to 5, what is the curve doing? So let's put this as 10, for example. Look, 5 somewhere around there. Okay, a big number there. Let's put this as, let's say, 20. So there is 5. If this is 20, 5, 10, 15, 20. Okay, so the most people in right up. This has 50. All right. So as far as I can see, the gradient is positive. But just to confirm, what you simply do, yeah, f of x is equal to, right? So you can have f prime of x. So that means the differentiation, the differentials. Okay, so now what we need to practice now, you don't necessarily have to show all the workings of 3 times 4x cubed. Okay, now this is a sum function, so we can differentiate each term by itself. Can somebody please just look at this and just tell me what is the differential of that term there? Because that is what, at that stage, at that level, that is what will be required of you. You don't have to show all these little itty-bitsy detail of the working. Just, you should be able to just look at this based on what we discussed earlier on, all right? Based on what we discussed earlier on, and just apply the rule. You can apply it mentally. You don't have to demonstrate it, because this will be like baby steps, and just write the differentials of that piece there. Okay, because really and truly, the differential of that piece would be the differential of this entire function, because this is a sum function, it would be d dx of 4x raised to the power of 3 minus, okay, so it's a sum function, so it's minus d dx of 5x raised to the power of 2 plus d dx of 3x minus d dx of 15, because it's a sum function, so you can find the differentials of each term, and that will give you the differentials of the entire function. Okay, so can somebody please tell me what is the differentials of 4x cubed? Okay, so this working I just did there, it would be wise to do it, to show it. If you don't show it, I will not really penalize you, but we would practice to show that's the differential of this sum function. So what are the differentials of 4x cubed? Now I'm just stressing the fact that we can apply the differentials to each piece, each term, because it's a sum function. It's a minus, it's a plus, a minus, a plus, and a minus. So because of this, we can find the differential of each piece. Later down, we're going to do functions when this is not the case. This is a product. We cannot do this, what we just did there. This is a quotient. We cannot do this, what we just did there. But for a sum, you can find the differentials of each term because of the sum. The sum of the differentials is the differential of the sum. Okay, so what is the differentials of 4x cubed? Anybody? Well, 12x squared, right? So you just multiply 4 3s are 12, you subtract 1 from 3, will give you 2, minus 5 2s are 10, 10x, because subtract 1 from 2 will give you 10, plus the differential of 3 is 3, and the differential of 15 is 0. Okay, and therefore what you do now, you find f prime of 5, gradient of the function, all right, when x is equal to 5. So f prime of 5 now, so all you see 5, x, you substitute 5 in the gradient function, and then you evaluate. To 53. Okay. Hence, at x equal 5, the function is increasing at rate of 253 with each unit. All right, increase of x. Okay, so that's basically what you do for number 4.